Okay, so hello everyone, and today I'll be presenting on our graphical user interface, okay, which is SLIND version 2. So this is our main interface, which I will be talking about, okay, for the rest of the presentation, and I will also very briefly introduce to you the side panel over here. So this side panel is also important, but it is not the focus of our presentation today. However, it is related to our presentation. Okay, this side panel allows us to stream data continuously, okay, from some of these social media sources. So we can stream data continuously from our from the Common Crawl repository, okay, from YouTube, from Twitter, okay, from some of these other social media sources as well. Okay, and what this interface will do is also to perform sentiment analysis, okay, on the social stream, on the social data stream. Okay, so if I hit on the Twitter, which we'll be using for our presentation today, if I hit on the Twitter option, okay, and I click on the centralized button, okay, you can see that data is being streamed directly from Twitter, okay, and as you can see that some of these values are basically appearing. Okay, so these values are basically have been analyzed, okay, and have been analyzed for sentiments. Right, so these are sentiment values, okay, which we'll use in our main program over here. Okay, so this is our main program, and this is our main graphical user interface. Okay, and while this is going on in the background, okay, this program is ready to learn. All right, so our graphical user interface, okay, is basically from an extension from SLIND version 1. So this is SLIND version 2, okay, and SLIND version 2, okay, basically builds on SLIND version 1, and it basically contains now a learning algorithm. All right, so it basically contains on the overview, all right, a generative adversarial neural network architecture. Okay, and inside that generative architecture, okay, we have two of these fractal neural networks, okay, which basically one of them acts as a generative fractal neural network, okay, and the other one acts as a discriminative fractal neural network. Okay, so both of these fractal neural networks, they can be considered to be hybrid deep learning models. All right, so over here at the interface, okay, we can see that there are a lot of categories, okay, that allow the user a lot of control, all right, over what the results are and what gets displayed on the screen. All right, so some of these categories, okay, have been elaborated in SLIND version 1 and will not be touched on in today's presentation. Okay, so the file operators category, the graph category, the univariate category, the multivariate category have all been elaborated in the previous presentation. Okay, so for this demo, okay, it will not be elaborated, okay, because this will be an extension. Okay, so what's new in SLIND version 2 will be the tuning category. Okay, so in this tuning category, okay, we have first of all the learning rate. Okay, so tuning the learning rate allows your model to learn faster. Okay, so the higher the learning rate, okay, means that the faster, okay, you will converge to a prediction. All right, and the lower the learning rate, okay, means that you learn at a slower pace, okay, and that you will converge slower to your prediction. Now, obviously, they have their pros and cons. Okay, so the higher the learning rate, the faster. Obviously, you got speed. Okay, but your predictions won't be as accurate. Okay, so accuracy is trading. You're basically trading off accuracy for speed here. All right. So for sliding window, so the sliding window here, okay, pertains to how many streams of queries, okay, you want to learn at once. Okay, now obviously this is going to consume more resources as the number of concurrent streams increases. Okay, so we'll just leave this at the default of 3. Okay, so next up is the error tolerance. So error tolerance, okay, allows you to determine, okay, how much error is acceptable in each epoch. Okay, so whether or not you accept or reject an epoch, okay, depends on how much error, okay, the learning results basically come up with. All right, and then you've got your outlier threshold. Now this outlier threshold is directly applicable to your data. Okay, so you need to specify, okay, how much of a noise is acceptable, okay, in the data that is used for your learning process or for your learning phase. All right, and obviously the model also needs to know what's the valid ranges of data that it can actually look at. Okay, so because it's basically very application dependent. Okay, some applications um, um, only have a very tight range of data, while other applications have a very wide range of data. So you need to specify, okay, how wide or how tight, okay, your data ranges are, okay, so that your model will be able to learn adequately. All right, and then you've got your scaling, so you can scale your data as well. Okay, so for some very specialized applications that require scaling of data, okay, you can also specify what your vanishing and your exploding gradient thresholds are. Okay, and these are actually some of the parameters that are used in some of these models, okay, which have a stochastic gradient descent method. Actually, most of them have stochastic gradient descent method. Okay, so you need to specify, okay, what your thresholds are, or you can specify, or leave it as, okay, default values. All right. Because we are using fractal structures, okay, so fractals are basically atom structures or atom architectures, okay, that can grow dynamically. Okay, so they can expand in depth or they can shrink, okay, depending on the complexity of some of these relational and sentiment values that have been transacted, okay, in the social stream. Okay, and then you also can specify trust region radius and regularization parameters. Okay, and so we'll just leave all of these values at default, okay, for our demonstration. Okay, so over in our models category, okay, we have here our activation function. So you can specify, okay, from this drop down list, okay, which of these activation functions you want to use. So it's pretty comprehensive, okay, and there's some of these very well known activation functions here already. Okay, now hitting clicking on the spiking activation function, okay, transform your neural network into a spiking neural network. All right, and spiking neural network basically will spike a neuron, okay, based on the cumulative effect. Okay, so you will have a threshold for that spiking effect. Okay, so it's different from some of these activation functions which are sigmoidal based or ReLU based or leaky ReLU based or some of these other functions. All right, so we've got also your standard deviation and your hyperparameters, okay, that you can basically tune for some of these activations as well. Okay, and below that, okay, we have our models, okay, our learning models, okay, and these are our baseline models, okay, which you can basically use, okay, to build your fractal or to morph your fractal into a structure. Okay, so we have our single layer perceptron, our multi-layer perceptron, okay, or some of these restricted Boltzmann machine, digital autoencoder, deep belief network, so on and so forth. Okay, so for this demo, okay, I'm just going to choose a single layer perceptron baseline model, okay, to build my fractal neural network architecture. Okay, and over here, okay, we have our controls category. So our controls category allows us to control, okay, which of these information we want to see and which of these information we want to throw away. Okay, so we can choose to log learning metadata. Okay, we can choose to see our convergence. Okay, we can choose to see our verbose. Okay, our profile. Okay, we can choose to see our generative output. Okay, we can choose to see our bias. Okay, or we can choose to log our learning results or testing results. Okay, so for a start, okay, I'm just going to log our learning results, okay, for our demo. All right, so I'll just click on the learn, okay, button, okay, and basically, as you can see, okay, this pop-up has appeared. Okay, so it tells me, okay, what are my parameters. If I click OK, okay, and it tells me what's the model which I've selected. Okay, so it says here I've selected a single layer perceptron. Okay, I click OK, okay, and it tells me that this adversarial learning stream has started. Okay, and as you can see, okay, from this text box over here, okay, this learning has already started, so it continuously learns. Alright, so at any time, okay, during the learning process, if I want to test, okay, the results of my model, okay, or if I want to test the adaptability of my model, I just hit on the test button and it tells me that the data stream window testing has completed. Okay, and over here, okay, I have an empty folder, okay, which will contain all of my results, okay, all of my testing results and my learning results, okay, which I have logged from my controls department or from my controls category. Okay, so if I hit export in the files category, okay, it tells me success, and if I go back to my folder, okay, I can see that some of these testing results have already been logged. So if I click on one of these results, for example, okay, I can see that all of these results, okay, are shown on my Excel file, okay, and I can then print from that. All right, and then finally, okay, I can also render a hypergraph. Okay, so if I click on this button, okay, a 3D image, okay, of that learning model comes into the picture. Okay, so I can scale, I can zoom, I can move it around. All right, I can move it around. All right, and that ends my presentation. Thank you very much.